Hi, hello, I'm Abdurrahman, and now I'm going to talk about problem statement. Manual monitoring system in a long time have been the way that hospitals have been using, and it's not the perfect way or the most suitable way, because using the smart monitoring system, we can save some money and upgrade our quality for monitoring system. Going to the objectives, we have three main objectives. The first is to develop a smart monitoring system that enables to transition from the hemodialysis system from manual to real time, which means instead of the personnel or the worker go every time to take the records manually, this will be automated and sent to the needed person. Second, to reduce equipment downtime and increase the lifespan of water treatment. This careful, censored way of treatment for the water will increase the lifespan of the water itself. Third is to minimize and eliminate human error. The personnel or worker will go every time to check the liters and stuff. It highly get an error because we are humans, so make it a smart monitoring system which will reduce this error chance. Thank you.
Hi, my name is Tam Xiaowei, and for the part of methodology, I will focus on the water purification system, while the another one is smart monitoring system will be passed through my groupmate, Esther. In this project, water purification system is developed by following the hemodialysis quality and standard which established by the Medical Service Unit, Medical Development Division and Ministry of Health Malaysia. And in this standard, the component of system might include the raw water tanks, raw water pump which to ensure the pressure is enough to pass through the water, and a multimedia sediment filter to filter out the large particle, and the carbon columns to absorb the odors of the water, absorb the chlorines, and the softener columns to solve the water quality, and the gut filter to protect the RO membrane, and the RO membrane which stands for the reverse osmosis membrane. Here is the three key steps that we mentioned by the international standard. The first one is the pre-treatment, which include the water softener and the carbon absorptions. And for the second one is the primary purification, which include the reverse osmosis system. So in this step, they will have the reverse osmosis membrane to be used. For the third one is the distributions. It's mentioned that how the raw water after filter, it becomes clean water, how the clean water be transfers to the hemodialysis machine. In this slide, it shows the filter that we have used for each key step. So at the pre-treatment, we use the sediment filter to filter out the dark particle. And for the nano-civil GAC filter, it actually has a similar function with the both pre-carbon and the post-carbon. So for the carbon filter, it's actually used to remove the odors of the water, or we know at the bad test of the water. When the water is treated to be used in our daily life, it will include the chlorine and the fluorine. So the function of the carbon filter is to remove all of the chemicals. So after this, we will enter to the primary purification, which we will use RO membrane to filter out the water.
Hi, I'm Esther Chang. For my part, I will explain about the hardware for smart monitoring system. As you can see from this slide, this is the circuit that we use in the system. By using this circuit, we actually managed to get our expected result for the smart monitoring system of water treatment in hemodialysis machine. Firstly, I'll explain about the microcontroller that we use in this system, which is NOT MCU EXP32. From this slide, you can see that we got 6 features for the EXP32. Firstly, is about the connectivity. It is the biggest advantage of this EXP32, which it supports both Wi-Fi and Bluetooth, make it ideal for IoT application, which allows seamless communication with other devices and cloud platform. EXP32 have dual-core design, which makes this microcontroller can do multiple tasks at once. EXP32 also can collect data from sensor, controller device, and talk to other devices in a network, which make it very useful for automation and monitoring. From this feature, can show that the EXP32 is a powerful, energy efficiency microcontroller with excellent connectivity and multitasking capability. This makes it ideal for IoT-based application like our smart monitoring system. Now I will explain about the sensor that we use in this smart monitoring system. The sensor that we use are flow rate sensor, temperature sensor, pressure sensor, and TDS sensor. The function for each sensor is shown on the slide. As you can see from flow rate sensor, it used to monitor water flow from the pump, which helps us to calculate the amount of water flow through the filters. For temperature sensor, it's used to measure water pressure. This is because we need to let the temperature stay in the range from 35 degrees Celsius to 37 degrees Celsius. After that, for pressure sensor, we use to measure the water pressure change of water. The water pressure need to remain below 100 psi to prevent damage to the filter. Lastly, is for TDS sensor, is used to monitoring water quality and purify. It can ensure the water quality by measuring the total dissolved solid in part per milli. The other component that we use in the circuit is LCD, resistor, buzzer, and LED. LCD we use to display the parameter, and for resistor we use to limiting or regulating the flow of electric current in electrical circuit. For the buzzer and LED light, we use to allow the failure of sensor, which are we using power bank for power source. We're using pressure regulator to maintain optimal water pressure for filtration. And lastly, we're using water pump to pump up the water.
Hi, I am Aziza Sofia, and I will walk you through the IoT implementation in our project using Arduino IoT Cloud, covering the setup process, coding, dashboard integration, mobile application, and data retention with the export capability. Hi. Starting with the setting up of Arduino IoT Cloud, we started by setting up of our ESP32 microcontroller in the Arduino IoT Cloud environment. The first step was to detect the ESP32's IP address and establish a secure Wi-Fi connection by entering the network SSID and password. Arduino IoT Cloud then generate a unique device ID and secret key, which are crucial for secure communication. Since the secret key is only available once, losing it requires us to re-register the device, and this adds on to the layer of the security of our system. For software development, we use the Sketch section in Arduino IoT Cloud to write, edit, and manage our project code. This section allows us to define constant, configure the sensor pins, and implement the logic for data collections and alerts. Once written, the code was verified, compiled, and uploaded directly to the ESP32 via USB connection. Another advantage of using Arduino IoT Cloud is its over-the-air function, or we call it as OTA. This function allowed us to upload the code remotely without requiring a physical USB connection to the ESP32, making the maintenance much more convenient for us. To visualize the collected sensor data, we utilize Arduino IoT Cloud's interactive dashboard that allows real-time monitoring with customizable widgets as shown in the slide. This makes the data interpretation more easy and user-friendly. We also utilize the Arduino IoT Remote mobile app that is available for download from the Google Play Store. These apps provide real-time monitoring and control from anywhere. Through this app, users can check sensor data and system status on the go. Importantly, we receive the instant notification directly on our mobile phone whenever the ESP32 goes offline or detects any malfunction from the sensors. This ensures that any issue can be addressed promptly, improving the system efficiency and reliability. The last key feature of Arduino IoT Cloud that I want to highlight is its data retention and export capability. Our dashboard will store the sensor data for up to 15 days, and users can download the historical data in CSV format for further analysis. This feature makes our system not just a monitoring tool, but also a basic data logging solution.
This is our prototype for smart monitoring system for units. This is our device, which is Purivo XV. So our device is here to measure four things, which is the flow, pressure, temperature, and conductivity. Each one had a different LED with a different color. Once the sensor don't recognize any perfect number, the LED will be turned on, which means that there's something goes wrong, and there's a limit for each one. Now we're going to see how it works. As you can see, all the lamps are off. This means that the sensor has measured numbers, and the numbers are right. Here, as you can see, we get the good quality water, which has been filtered, and this is the unfiltered water. Using Arduino IoT Cloud, we can see all the data have been sent here. Here you can see the water flow. It starts from the flow rate sensor, goes to the water regulator, ends with the pressure sensor, and go for the four filters here, ends with the RO membrane. From the RO membrane, we will have the two outputs, which is the filtered water and the other water.
As the conclusions for this project, we have successfully developed a smart monitoring system in water purification of hemodialysis, and also we successfully integrated real-time monitoring, IoT tracking, and automated alert. We also introduced the method to minimize the human error, and also the method to reduce equipment downtime and enhance the system efficiency. For the future improvement, we can optimize the sensor accuracy for better real-time monitoring, and also we turn to enhance data analysis for more precise system diagnostic, and also the refined alerts mechanism to reduce false alarms and improve response time. Thank you.